During my time in construction civil engineering over the last decade, I took pride in delivering infrastructure projects and making our lives better. But it very quickly became apparent to me that construction has an environmental cost. Now, being an engineer is about solving problems and improving our standard of living. And so I was disappointed to find that it wasn't as simple as this. Construction does make our lives better, but arguably one of the largest components of it, cement, has a huge environmental impact. 90% of all cement factories today still run on coal. You heard correctly, 90%. And so it's no wonder that cement contributes 7% of all greenhouse gas emissions every single year. In terms of concrete, we consume 3 tons of concrete for every single person on this planet every year. That's 3 tons for me, 3 tons for you, 3 tons for every single person in this building. But just imagine a substitute that consumed 25% less energy to produce than traditional processes. It's carbon negative and eliminates coal, bringing cement into the 21st century. And that is exactly what we are doing at Reaforma. We are making clay-based cement. We are doing that with a process called pyrolysis-powered calcination. Now, what does that mean? Well, no traditional combustion. Carbon is stored in the process rather than expelled, and production of high valuable resources such as biochar. And yes, there are other companies producing cement solutions out there, but no one in the world is commercializing carbon-negative calcined clay efficiently. So this means we can help with the transition to decarbonizing cement more effectively. Now, the IPCC and the IEA estimate that calcined clay or clay cement will make up 400 million tons of the market by 2050. The market will be about 3 billion in 2030 and 28 billion in 2050. And if we applied our solution to this market, we could save 273 million tons of CO2 every single year. We've already begun partnership discussions in the UK with concrete suppliers and multinationals across France, Switzerland, Germany, and the US. But we begin by focusing our efforts in the UK on ready-mix concrete suppliers. Since 2024, we've already raised £65,000 in proof-of-concept pilot funds. We've secured grants and raised 250K in funds from people like Carbon 13 and the Net Zero Technology Centre. We've produced 200 samples from clays from one of the largest construction sites in Europe, HS2. And we've already begun conversations on LOIs with the UK's largest privately owned concrete company. We've got letters of support from Skanska, Lang O'Rourke, Mineral Products Association, Imerys, a global mining conglomerate, as well as Imperial College London. We're a team of engineers, we're a team of engineers, consultants, business strategy people, and scientists. And we've already got people working in the lab, developing and pushing along down our TRLs. We're currently raising £1 million in our pre-seed today, and we secured 30% of that in soft commitments, and we'll be using that funding to build the first lab-scale prototype of this continuous system. With that, we'll deliver on live demonstrations on real construction sites in the UK, and we'll take that data and we'll use that to do a scaled-up design to produce a 1,000 to 5,000 ton demonstration site in 2026. Decarbonizing cement requires ambition and courage, not just from Reaforma, but also from investors and other people of the like. So if this is something of interest to you, please come and have a chat. My name is Manraj Sembi. I'm the CEO and founder of Reaforma. Thank you for your time.
Well done, brilliant pitch. Let's move on to questions now. And as you submit yours using the QR code on screen now, let's kick one off with the fact you mentioned in your presentation that there are other new low carbon cement solutions which currently exist. So what's your biggest advantage over them?
Well, actually, compared to traditional, new cements out there, their biggest barrier is the standards of regulations. There's new standards that have to be implemented to actually adopt these cements, whereas ours actually comply with all British, European, and American standards right now today. So If you come and have a chat with us later on, you'll see some of our samples. They could literally be used on any construction site today. I would say that's probably our biggest advantage.
25% less energy intensity is great, says one audience member. But what is your manufacturing plan? Retrofit existing facilities or build from scratch?
That's an interesting question. Well, by 2030, 30% of all kilns today will be end of life. So they need to be replaced anyway. So there's definitely a big demand to produce new facilities. In terms of clay-based cement plants, we currently have the capacity for less than 10 million every year, and we need 400 million, so new plants are needed. But from a technology perspective, we will probably concentrate on isolating and doing the system as a whole, and then refining that to be implementable to old plants globally. So it's more from a technically driven direction. But we do plan to retrofit at some point in time. This actually can be more costly if you retrofit.
Okay. Moving on to another question. How is the quality of the cement compared to the conventional type?
I like this question, actually. We actually perform better than traditional OPC. So I think, let's call, I'm not going to use any technical terms, but about 50 to 60 megapascal is what we've seen from traditional Portland cement. And we demonstrated quite recently that we can achieve 68 megapascal. And we're also currently working on improving the early strength of our cement today. So there's no compromise on quality.
What intellectual property do you have on your process?
We filed a patent in June, but I mean, I've got to owe it to the technical team and everything we're doing. We already need to file another patent because we've already found new intellectual property. So the intellectual property is actually on the process of how we've combined these two things, and namely a unique heat recovery in the system as well. So we do have IP, but there'll be significantly more IP developed in the process. Naturally, it's a very tech-heavy innovation.
Okay. Another question then asks whether you're building a plant yourselves, or can your tech be delivered by existing plants?
It could be delivered by existing plants. That would require a lot of upfront readjustment of a plant. What would be better would be to partner with an existing industrial incumbent, and that's what we plan to do. So Imerys Mining, they have 250 global industrial sites. We've already got proof of concept with them, and really we want to push that and turn that into a partnership so we can deliver the first site, so our demo site in 2026. So we've already established what the criteria is for that, and yeah, that's our plan.
Where do you get the clay?
We've been getting the clay from HS2. So this is good for one thing, actually, HS2. Your money is going somewhere. But usually, so a lot of the clay, the way construction works is there's a lot of preliminary activity that happens before construction occurs. So you can get very pure quality clays from the excavation activities prior to the structure that goes up that you see. So you can get clay there, but also the clay that we need is probably one of the most abundant materials all over the world, US, Europe, America, Asia, but more importantly, it's abundant in the places where the next 80% of construction will occur, in the global south, places like Africa and Asia. And our solution is really, it will be able to make an impact in those places too.
Fantastic. That brings us to time. Thank you. Well done.
Thank you so much.